In this video, we're going to introduce you to the point-slope form of an equation of a line. So we've already done some work with slope-intercept form of an equation of a line. This is another form of a line called point-slope form. I'm going to tell you where it comes from. It really comes from the slope formula. So I want you to recall the slope formula between 2 points, and that we found it by subtracting the difference of the y's in the 2 points and put that over the difference of the x's in the 2 points and made that fraction. So to derive the point slope form, what we do is that we, instead of using this second point x2, y2, we use a generic point x, y, and then calculate the slope between those 2 points. It looks like this. Let me show you. So we take our 2 points, x1, y1, and our generic xy point, and we put them through the slope formula. So we would get m equals y minus y1 over x minus x1. So you're probably thinking, why did we change that x2, y2 to just xy? Well, x1, y1 are going to be numbers, but x and y, that point, those are the variables, just the letters. Okay, so notice how I took the difference of the y's and then the difference of the x's and formed that slope formula ratio, right? Cross multiply just to get rid of the fractions there. And so then I'm going to get m times x minus x1 equals 1 times y minus y1. So you've probably done some previous work on cross multiplying, right? And then I'm going to get rid of this product right here. 1 times y minus y1 is just y minus y1. I'm going to put that on the left-hand side. I'm going to switch the order of the sides. So I get y minus y1 equals, and then m times x minus x1. So as you see that form right there, that's called point slope form. And again, we got it from the slope formula, the slope of a line between 2 points. We were pretty clever there, and we substituted 1 point with the letters x, y. Okay, we're going to use this point slope form. So let's start that work now. Okay, so there is our point slope form of a line. It's y minus y1 equals m times the quantity x minus x1. And this is the form that you would use if you would be given the slope of the line m and one other point that's on the line. And the difference between this form and the last form, in our last video we used the slope-intercept form, was that we were given the slope, but the point that we were given was the y-intercept. In this form, point slope, they can give you any point on the line and you can use it to find the equation. So let's do some examples now. So notice that in our first example, it asks us to write the equation of the line in slope-intercept form. They do want the final equation in slope-intercept form. And then we are given the slope and 1 point. And can you tell that that's not the y-intercept, that point? How can you tell that that point is not the y-intercept? This is really important. You should know this. Okay, if you said because the x is not 0, the x-coordinate, you're absolutely right. So this is not the y-intercept. But instead what we're going to do is we're going to label it. We're going to label this point x1, y1, and then of course we have our m equals 3. And then the next step is that we're going to substitute those values into our point slope form. So here's our point slope form again. You should have this written down in your notes when you go to do this homework. Memorizing it is awesome as well for your first test, but there it is for now, okay? And we're going to literally just substitute these values in. So y minus 5, right, because we decided y1 was 5, equals m is 3, times x minus, and then x1 is 2. So see how we substituted everything in? This is good, and as your instructor looks at your work, they're going to be looking for that first step, okay? So now we're just, notice how they wanted us to write the final answer in slope-intercept form. And slope-intercept form is that y equals mx plus b. In other words, we have the equation solved for y, right? So we need to keep going. We need to keep simplifying here. And so the first thing that I'm going to do is go ahead and use this distributive property over here, right? So y minus 5 equals 3x minus 6. And then I'm going to add the 5 from both sides so that I can get that y by itself, because that's critical if we have our slope-intercept form. So now here we go. Here's our slope-intercept form, which is how they wanted us to leave the answer. Now, if you would like to check this equation, we can substitute back in the 2, 5 and see if it works, right? Because the m, we can see the m. We can see that we got 3 for m, so that worked. Okay, so let's check the point. So 5, does that equal 3 times 2 minus 1? 6 minus 1. Ah, perfect. So that works. So did you follow those steps? We're going to try those same steps in number 2, so you get the idea. Okay, so now in our second example, m is negative 5, 6, so it's a fraction. Don't freak out. Point is 6, 7, so we're going to label that x1, y1. Okay, so we've got those labeled, and there's our m. So again, the point slope form is y minus y1 equals m times x minus x1. Okay, so let's substitute in y minus y1, which is 7, equals our slope m, which is negative 5, 6, times x minus, and then our x1, which is 6. Okay, good. So make sure that you show your instructor this step before you distribute. So here comes our next step. We're going to go ahead and distribute because we do want that final answer. They've asked us to put it in slope-intercept form, which means we need to isolate y. So the first step is to distribute. So y minus 7 equals negative 5, 6x plus, because a negative times a negative is a positive. Now over here, this is kind of nice. They give us a nice point. As I multiply across for those fractions, I get 30 divided by 6, don't I? Which is 5. So no fraction there. That's kind of nice. Okay, and then our last step here will be to add the 7 to get that y by itself, because that's our slope-intercept form. And so we get negative 5, 6x plus 12. Okay, and I'm going to leave the check to you, but there's our equation. Let's do a couple more. Okay, once again, we have our m given, our point. Let's label the point x1, y1, and then our point slope form, which is y minus y1 equals m times x minus x1. And we're going to substitute, so we get y minus 3 equals negative 4x minus a negative 2. So now we're going to distribute. I'm also going to change these signs here to a plus. Okay, so we're going to have distribute here, and we get y minus 3 equals negative 4x minus 8. And now we're going to add 3 so that we can get that slope-intercept form, right? So both sides add a 3. So y equals negative 4x minus 5. And again, I'm going to leave that check to you. Are you starting to get the idea? I'm going to let you try the next one. Here's the next problem. You're given your slope, which is a fraction, don't freak, times the point. I want you to go ahead and pause the video here, and when you unpause, you'll see the answer. So try it. Try this one on your own. Okay, so here's my answer. Y equals 3/4 x minus 11. Check this against your own work. If you didn't get the right answer, check your signs. Okay? Okay, let's go to the next two. The next two are different. So let's go ahead and take a look at them. Okay, now they're wanting us to find an equation of the horizontal line that contains this order pair. So x1 and y1 are negative 1, negative 9. What's the slope of a horizontal line? What's the slope? Slope is 0, right? All horizontal lines have slope 0. Have you memorized that yet? Okay, so we're going to use that. And so now we get y minus a negative 9 equals 0 times x minus negative 1. Okay, but gosh, over here on the right-hand side, we just have 0, don't we? 0 times anything is 0, so we get 0 here, and then here we get y plus 9. And then subtracting 9 from both sides, we get y equals negative 9. And that looks like a horizontal line equation, doesn't it? Because those are the equations that are y equals a number. And by the way, you don't have to do all of this work. If you just are able to remember that this equation for a horizontal line is y equals a number, you can look at the y value of the order pair that was given, and that will be your y, right? Does that make sense? if my horizontal line has to go through the point -1, -9, then that means that -9 is the y value of all the order pairs on that horizontal line. So you can skip right to this equation, y equals -9, which we're going to do with number 6 because look at what it's asking for. Now we need the equation of the vertical line containing that point -1, -9. And you remember that the vertical line, the slope is undefined, right? So it makes no sense to talk about an m, anything we can substitute into the equation. The other thing is that, do you remember that the vertical lines have equations x equals a number? So here we have that, and let's do a little graph here so you can kind of visualize that. -1, if -1 is here and -9 is down here, there's our point, yeah? -1, -9. And they want a vertical line that goes through that. And so that would look like this, wouldn't it? So what would be the x value of all those order pairs on that red line? And if you say x equals -1, you're right. And that is the equation of the line. And we can't talk about putting it in slope-intercept form because there's not even a y variable for us to solve for, right? So that's why I'm saying that these horizontal and vertical line equations, once you know their general format, you should be able to just find them by sight just if they give you 1 point. Okay, I hope that makes sense. Just keep practicing and memorize that point slope form. Okay, good.